So this chapter will be on chapter 6F on 3D shapes. In this chapter, you'll learn how to name a 3D shape and how to draw a net for a 3D shape. So first of all, we need to talk about three-dimensional shapes, 3D shapes. When we look at a three-dimensional shape, we need to think about three things. Number one, the flat surface of a three-dimensional shape is called a face. So if I were to shade this area in, that would be one side, that would be called a face. The point in which all the edges meet is called a vertex. Vertices for plural. The edges, basically these parts that I'm highlighting that connect the faces, are parts that connect the faces. Now we need to start naming these shapes. When you have a three-dimensional square, it's basically your cube. When you have a three-dimensional rectangle, this is called a rectangular prism. Or, better known as, a cuboid. Not a cube, but a cuboid. Now, this shape right here is called a prism. However, the shape of the cross section, meaning right here what it's made out of, is the type of prism. So in this case, this one is called a triangular prism, because at the cross section, the green part, it's made out of a triangle. Now this last three-dimensional shape is a type of pyramid, because for a pyramid to happen, all the edges drive up and meet at a point. So this is what is called a pyramid. However, in order to know the type of pyramid it is, we have to look at the base. So in this case, I see 1, 2, 3, 4, 5 sides. And a shape that's five-sided is called a pentagon. So in this case, this is called a pentagonal. Oops, ignore the spelling on that. Pyramid. Now the second skill is to simply learn how to draw a net for a three-dimensional shape. So in this situation, we have a cuboid. So we know it's not a cube, but it's a cuboid. So it has to be rectangular, with the dimensions of 4 centimeters by 3 centimeters by 1 centimeter. So first of all, we need to remember that in a three-dimensional shape, there is a length, a width, and a height. And for this demonstration, I'm going to use length, height, and width. Now it doesn't really matter, because keep in mind, three-dimensional shapes can rotate as long as you have these 3 dimensions somewhere along the shape. Step 1 is to visualize, draw the cuboid. On grid paper, draw the net of this cuboid, and then 3C, find the total net area of this net. So I'm going to demonstrate how you do this on grid paper. So first of all, we have a shape that is 4 by 3 by 1. And I labeled this as my length, my height, and my width. So first of all, I'm going to go ahead and I'm going to visualize it. So if I were to take cubes and stack them, I would have 4 cubes stacked sideways that looks something like this. Okay, so that's the length of it. Now the height means I need to, it's times 3, so that means I need 3 rows of this. So here's another row of 4 cubes, and here's one more row of 4 cubes. So now my length is 4 centimeters, and my height is 3 centimeters. Okay, so I've met the 2 objectives, but I still have one more. I need my width. Now on grid paper, what you need to do is show that it's 1 cube wide. So I had to take the corner, the vertex of this square right here. I'm going to draw to the diagonal edge of that square. So that makes one of my edges. Then I'm going to continue that same pattern until I've done that with all the edges. And I'll continue that same pattern with all the edges. And then just simply fill it in. And there you go. You have your dimensions met. It's 4 long, 3 tall, and 1, like this, centimeter wide. So height, length, and width. Now we have to draw the net of the cube, and again I talk about it as a 4 by 3 by 1. Length, width, height, and width. So first we have to draw it as if we've unfolded it, because a net is an unfolded box. So we know that the front looked something like this. And then we also know that the width, when we unfold it, has to be 1 centimeter. And then keep in mind, because a cuboid has 6 sides, that these two have to repeat. So here's one more version of that, and then here's another version of the side. Now finally we need to, so if we folded this, this would make a box that doesn't have ends on it. So now we have to add the ends. And what you have to do to figure out how to add the ends is simply to look at how, for example, if I wanted to draw one of the ends here, I have to look and see how long the attached end is. So since it's 3 squares long, I have to make this part 3 squares long. And therefore, I'm going to do the same thing here and make this 3 squares long. Now, this isn't just the one way to do it. You can also put those flaps somewhere else as well. So, another place you can put it could be along the larger ends. So if I wanted to place the edge here, I have to look and see how wide that is. Okay, so it's 1. So I'm going to go ahead and just make sure that I just draw the width to be 1. And there you go. I just draw how tall it is. And I can do the same thing on the other side. Same thing. So there's many different ways you can draw a net. The goal of the net is to make sure that there's 6 faces in order to close the box. And if this is difficult for you, I recommend drawing it on paper, cutting it out, and folding it and see if it works. Finally, to find the total area of the net, what you have to do is, if you have that net, so here's a quick sketch. All you have to do is figure out the area of each space. So this rectangle right here has an area of 3 centimeters cubed, squared. This area is 12, 3, 4, 12, and 4. So if you add that all up together, 3 plus 12 plus 3 plus 4 plus 12 plus 4, this should add up to 38 centimeters, and since this area, squared. Now let's try one on your own. So the dimensions of a cuboid are 3 centimeters by 2 centimeters by 2. Visualize and draw the cuboid on grid paper, draw the net of the cuboid, and then find the total area. So at this time, pause. Okay, so now I'm going to go ahead and just reveal immediately. And keeping in mind, you might have a slightly different answer, but if you have the same idea, if you rotate the shape or move things around, or have it should be similar. So here we go. So you have one that might look like the 3-dimensional shape that could look like that, a flat pattern that might look like that, but your area, we should all have the same area, 40 centimeters squared. And that's it.